In December 2022, astronomers pointed the James Webb Space Telescope at a patch of empty sky. They were looking for distant galaxies, maybe some early stars. What they found instead were thousands of tiny red dots that shouldn't exist. Objects so strange, so impossibly massive, that they broke every model we had about how the universe works. These dots are rewriting 13.8 billion years of cosmic history. And scientists are still trying to figure out what the hell they're looking at. The James Webb Space Telescope launched on Christmas Day 2021. It's the most powerful telescope ever built, designed to see further back in time than any instrument in human history. Its mission was straightforward. Look at the early universe. Find the first galaxies. Understand how everything began. But when the first deep field images came back, astronomers noticed something weird. Among the expected galaxies, there were these bizarre red dots scattered throughout the images. They were small, really small, just a few pixels across. But they were everywhere. Dr. Ivo Laba from Swinburne University was one of the first to notice. He ran the numbers on these objects and got a result that made him check his calculations 3 times. These dots weren't just old, they were ancient. We're talking about objects that existed just 700 million years after the Big Bang. But here's where it gets crazy. The mass readings didn't make sense. These tiny red specks were showing up as incredibly massive, like billions of times the mass of our sun, packed into spaces smaller than the Milky Way. And according to everything we know about physics, that shouldn't be possible. To understand why this is such a big deal, you need to understand how galaxies are supposed to form. After the Big Bang, matter wasn't evenly distributed. It clumped together over millions of years, pulled by gravity. Dark matter created the scaffolding. Normal matter fell into those structures. Slowly, over hundreds of millions of years, the first stars formed. Then, the first galaxies. This process takes time. A lot of time. The early universe didn't have supermassive galaxies. It had small proto-galaxies, baby galaxies still figuring out how to exist. But these red dots are showing mass estimates that rival mature galaxies. Some are reading as 100 billion solar masses. That's the size of the Milky Way. Except the Milky Way took 13 billion years to reach that size. These objects supposedly did it in less than a billion years. That's like watching a newborn baby grow to full adult size in 6 months. The physics doesn't work. You can't pack that much matter together that quickly. There wasn't enough time. There wasn't enough material. The universe was too young, too hot, too chaotic. Matter can only fall into gravitational wells so fast. You hit a limit called the Eddington limit. Push past that, and radiation pressure should blow everything apart. But somehow these red dots exist. And they're forcing scientists to rethink everything. The first explanation scientists jumped to was black holes. Specifically, supermassive black holes feeding on massive amounts of gas. When a black hole feeds, the matter around it heats up to millions of degrees. This creates an accretion disk, a swirling inferno of superheated gas. These are called quasars. They're some of the brightest objects in the universe. But here's the thing about quasars. They emit light across the entire spectrum. Ultraviolet, visible light, X-rays. The red dots only show up in infrared. They're not emitting the broad spectrum you'd expect from an actively feeding supermassive black hole. They're also too compact. Even quasars have extended emission regions. These dots are point sources, single pixels. Dr. Jorrit Matthey from ETH Zurich pointed out another problem. If these are all supermassive black holes, where did the black holes come from? Supermassive black holes need time to grow. They start as stellar mass black holes and build up by consuming material over millions of years. In the early universe, that growth process should be even slower. Less dense material, more chaotic conditions. So we're back to the same problem. Not enough time. Too much mass. Something doesn't add up. The second theory is simpler. Maybe these aren't as massive as they appear. Maybe it's just dust. Cosmic dust absorbs blue and ultraviolet light. It lets red and infrared light pass through. If you have a galaxy surrounded by massive dust clouds, it would appear much redder than it actually is. And the dust would make it look more massive because we're not seeing the full picture. Think of it like looking at a lamp through frosted glass. The lamp looks bigger and dimmer than it really is. This explanation solves the mass problem. If the dust is inflating the measurements, these could be normal young galaxies after all. But it creates a new problem. Cosmic dust doesn't just exist. It's made by dying stars, supernovae, and stellar winds. You need generations of stars to create the amount of dust required to hide entire galaxies. And in the early universe, there hasn't been time for that. The first stars were just being born. They hadn't lived long enough to die and create dust. So if these are dust-obscured galaxies, we have to explain where all that dust came from. We traded one impossible thing for another impossible thing. Which brings us to the most interesting possibility. What if the early universe didn't play by the same rules? Our models of galaxy formation assume certain conditions: star formation efficiency, gas cooling rates, dark matter behavior. These models work great for the universe we see today. But we're looking at an era of the universe we've never directly observed before. Hubble could see back to about 400 million years after the Big Bang. Webb can see back to 200 million years or earlier. That's uncharted territory. Maybe star formation was way more efficient in the early universe. Maybe the first stars were much more massive than we thought, burning brighter and faster. The first generation of stars, called population 3 stars, had no heavy elements. They were pure hydrogen and helium. Theory says these stars could have been 100 to 300 times the mass of our Sun. They would have burned incredibly hot and died quickly in supernova explosions. If there were more of these massive stars than we predicted, they could have built up galactic mass much faster than current models suggest. This would explain the red dots without breaking physics. We just need to update our models of the early universe. But we need more data to know for sure. Recent observations from Webb have started to narrow down the possibilities. In late 2024, astronomers used Webb's spectroscopy instruments to take detailed measurements of several red dots. Spectroscopy is like taking the light from an object and breaking it down into its component colors. Each chemical element leaves a unique fingerprint. What they found was surprising. The spectra showed signs of star formation, but also signs of active black holes. These aren't pure galaxies. They're not pure quasars. They're something in between. The current best guess is that these are compact galaxies with supermassive black holes at their centers, all shrouded in dust. The black holes are feeding, but not as violently as full quasars. The galaxies are forming stars rapidly, and heavy dust clouds are obscuring most of the light. This explains why they're so red. The dust blocks everything except infrared. It also suggests that galaxy formation in the early universe was messier and faster than we thought. Dr. Emma Curtis Lake from the University of Hertfordshire described them as transition objects. Galaxies caught in the act of rapid growth, but we're still piecing together exactly how they grew so fast. Here's what makes this discovery so important. The James Webb Space Telescope was built to test our theories about the early universe. And it's doing exactly that. The red dots aren't breaking the laws of physics. They're showing us that our understanding of the early universe was incomplete. We thought galaxies formed slowly and steadily. Turns out, in the first billion years, things moved a lot faster. The early universe was more efficient at building structure than we predicted. This has implications for everything: how dark matter behaves, how the first black holes formed, how the chemical elements spread through the cosmos. Every time we point a more powerful telescope at the sky, we find things that surprise us. The red dots are just the latest example. And there are thousands of them. We've only studied a handful in detail. The more we look, the stranger it gets. The James Webb Space Telescope is rewriting astronomy in real time. And the mysterious red dots are just one piece of the puzzle. Subscribe to stay updated as scientists figure out what these red dots really are. Because this story is far from over.